Hello, welcome back to the first lecture of week 8. So, we had already ended 7 week in which we have explored sequences, then series, then definition of a limit points, then differentiation, differentiability, and various theorems related to the differentiability like intermediate value theorem, Rawls theorem, Cauchy mean value theorem, Lagrange mean value theorem, generalized mean value theorem, and so on. Now we are at the verge where we will learn that successive differentiation can be applied for a given function. Why we are reading this successive differentiation? Some of the functions which you want to derive the higher differentiability of the complex function are so much complex than you cannot do manually, and therefore it is urged to use existing formula. So, in the successive differentiation, as its name suggests, we have to firstly derive first differentiability and then successively second differentiability of that function and so on. So, that is why its name is successive differentiation. So, let me start with, we will start with definition of successive differentiation, then some of the standard results, and then some exercises. So, we have started with one of the problem in which function is given. So, find sixth differentiation of a given function f(x) equal to x to the power 5. So, function is given and it has been asked that you need to find sixth differentiation. The first differentiation is, first derivative is just take y equal to x to the power 5. So, just take y equal to, so just take f of x equal to x to the power 5 and take differentiation with respect to x. So, this will give you 5x to the power 4, right. Similarly, take f double of x. F double dash of x is nothing but it is the differentiation of the first result. So, this results, right. So, you have to find out 5x to the power 4 this dash. So, this will be 5 into 4 x cube. Similarly, f triple dash of x, doing the same thing, f double dash of x, and then you will find out differentiation. So, this means 5 into 4 x cube differentiation, this will give you 5, 4, 3 x square. Similarly, you have to do the fourth one, the 5, 4, 3, 2 into x, then fifth one 5, 4, 3, 2, 1, right. So, you will take differentiation of x equal to 1. So, this is 120. Now, it is a constant function. This is a constant function. So, any higher differentiability will leads to 0. So, the sixth differentiability is what? This is nothing but you have to take it out on differentiability of the fifth one. This means I have to take 28 of this differentiability. So, it is a constant. So, this is why it is 0, right. So, answer is 0. Now, you can see that we have successively we have find out its differentiability. So, from the first, then you will get the second from the first results, then the third means the second one, derivability of the second one, and then so on. The fourth one, that means the third derivability of the third one, and so on. Now, the answer is 0. Now, using this approach, can we define successive differentiability? Yes. So, successive differentiation is the process of differentiating a given function successively n times, and the results of such differentiation are called successive differentiability or derivatives. The higher order differential coefficients are of utmost importance in scientific and engineering applications, and that is why successive differentiation is useful in many areas. So, let y equal to f(x) be a differentiable function, and let its successive derivatives be denoted by f dash x, f double dash of x, f triple dash, and so on, and fn of x. So, this is the n differentiability, n derivative of the function f(x). So, common notation of higher order derivatives, y equal to f(x). So, d by first derivative is d by dx, or it can be used d of fx or y1. So sometime we use y equal to fx, so y dash is equal to naught dy by dx, or sometime we can denote this one as derivative of fx, and this one can be written as y1, right. So sometime this notation y1, y2, y double dash, that is equal to d square y by d of x square, that is equal to d of dx of dy by dx. So this is equal to d of dx y dash of x, right. So this is equal to y2, right. So sometime this notation is quite important, and we use the subscript of the y. Nth derivative of the y can be written as yn and so on, right. So dn dx at x equal to a, that is equal to fna, right. Now we will go explore the existing results. That means some of the results are so well connected with the problems that you have to go through it, you have to memorize those things. It is going to be useful in your future when you will do the problems directly to find out the nth derivative of the given complex combinations of the functions, right. So firstly I have taken the polynomial function. Polynomial function is nothing but y equal to ax plus b, right, ax b power m, right, and we want to find out y1, y2 and so on, right, the nth derivative. Can you imagine how to do this? So let me give you y1. So for y1 you need to dy by dx. So this is equal to d of ax plus b m by dx. This can be done by d of ax plus b m, and since I knew x power m, so we have to use the chain rule, right. This is the same thing. Let me change the color first, right. So if I cancel it out, this is the same thing, and I knew the answer. This is equal to m into ax plus b m minus 1. And what is the differentiability of dx plus b with respect to the x? So this is a. So that will be your answer, right. Similarly, y2 means y2, that means I have to find out differentiability of dy1 with respect to the x, and this differentiability of y1, this means I have to find out m into ax plus b m minus 1 into a, and with respect to the x, right. So take these constant outside and try to find out this one. Using the same formula, you will have this m into a into d of ax plus b and m minus 1 divided by d of x. Use the same chain rule like this. So you will get m into a into m minus 1 into ax plus b and m minus 2 into a, right. So this will be finally comes out to be a square into m minus 1 into ax plus b and power minus m minus 2, right. So as you can see, if you have the second derivative, the a will have the same power. You have a second derivative, the a will be have the same power. And how many constant come in the picture? There are two constant, m and m minus 1. Similarly, can you find for 3? And here you will have the 2. So can you find for 3? y3? y3 is nothing but m into m minus 1 into m minus 2 into ax plus b, and this is m minus 3 into a3, right. So based on this, can we find yn? Yn is nothing but m into m minus 1 into m minus 2 till m minus of n into ax plus b, and this is m minus n into an. This can be written as factorial m divided by m minus n factorial and ap power m, right. So, factorial m into ax plus b m minus n into ap power n, that is your answer, right. So, m minus n, why it's m minus n, look at the structure you will have. So, it has a starting from m minus 1, m minus 2 to m minus. So, let me give you one of the hint first. So, this is m into m minus 1 into m minus 2 and so on to m minus n. Now, 1 into 2 into 3 into m minus n into this will be comes out to be it can be written as 1 into 2 into 3 into m minus 1, because this m minus n is nothing but going to be 1 to 3, right. So, that means this m into m minus 1 and so on to m to so on, right. So, this means factorial m, and since this was not there, so this will comes out to be m minus factorial n, right. So, that is how we will get this answer. So, factorial m minus n factorial ax plus b m minus n into ap power n when m is greater than n. So, there are three cases arises. The first case is if m equal to n. If m equal to n, what will be the value? So, we had find out yn is equal to factorial m divided by m minus a into x plus b p power m minus n into a p power n, right. So, m equal to n. So, put the value, this will becomes out to be factorial n divided by 0 factorial ax plus b, and m minus n is going to be 0 into a p power n. So, this will be factorial n, and this value is 1 and this value is 1 as well. So, factorial n into this value is 1. So, a n and all these has been the value 1. So, yn when m equal to n, that means if I find out ax plus b n, and then if I need y of n, then it will be nothing but n factorial a p power n. That is quite brilliant, thanks. I mean, you have to just find out the polynomial and the nth derivative is at your desk. Similarly, if m is positive but m is less than n, then yn is equal to 0. This is true only when m is greater than n. But what happens when m is less than n? M is less than n, then as you can go through here, it will be 0. So, it will going to be whole 0. If m equal to minus 1, then what happens? So, if you remember y equal to ax plus b power m, right. So, m equal to minus 1, that will give you ax plus b power minus 1. So, this will give you ax plus b power minus 1, right, and you need to find out the nth derivative. So, therefore, this will going to be minus 1 power n factorial n into a power n into ax plus b, and this will be n plus 1. That will be your answer, right. Similarly, now using this formula, using the formula we had derived for three cases, and for y equal to ax plus b power m, we had already derived y of n equal to factorial m divided by m minus n factorial and into ax plus b power m minus n into a power n. Now use this directly to find out if fx equal to 5x plus 3 power 8, find y5. You don't need to calculate each time if y1, y2, y3, no. You just have to do the same thing. So let's suppose this is equal to y. So y is given. Y means how much it is given? Y is given as 5x plus 3 and 8. So here m equal to 8, a equal to 5, b equal to 3, right? And we need to find y5. So n equal to 5. So I have to calculate factorial m. So y5 is nothing but factorial m divided by m minus n factorial, ax plus b p power m minus n and a p power n, right? Using the same thing. So here m5, that means we have to find out factorial 8 divided by 8 minus 5 equal to 3 factorial, and then we have to find out 5x plus 3, 8 minus 5 equal to 3 into a p power 5. A p power 5 means 5 p power 5, right? A p power 5 means 5 p power 5. So that will be our answer. And how much it will gives you? This will give you, let me calculate this. So this will be 125 divided by factorial 8 by factorial 3 into 5x plus 3 ka cube. That will be your answer, right? You can go through the simplification. So 125 guna 8 guna 7 guna 6 guna 5 multiplication 4 3 2 1 divided by 3 2 1 into 5x plus 3 ka whole cube. So 3 2 1 is cancel out, and this will be your answer, right? 125 cross 8 cross 7 cross 6 cross 5 cross 4 and 5x power cube. Now find the nth derivative of a given function. Function is in the polynomial where m is nothing but m is minus 1. Are you getting this one? So this is in the term y equal to 1 minus of 5x plus of 6x square minus 1. So here m equal to minus 1. For minus 1 we had the formula here f equal to m equal to, and yn is in that way minus 1 by power n and so on. So for this either you will go through this one and use the formula directly, this formula directly. So yn equal to, this will give you like this. So can we go through it? I think we will go through it. So let me, y of n is equal to minus 1 by power n into a p power n into x plus b minus n plus 1. So a to the power n into ax plus b minus n plus 1, right? So that is what the formula is. See, a p power n ax plus b minus n minus 1. I had left factorial n, so we will use here somewhere factorial n. Here n is equal to how much? Nth derivative. So this is the n itself. And how to find out? This will comes out to minus 1 n factorial n a. A is equal to, so to find the a, now you can see here, to find the 8 we have the 3 terms which is not in a desired form, that is ax plus b, and that's why we have to change this one in a desired form ax plus b. To do this you have to factorize first and then use the formula. So y equal to 1 divided by 1 minus 5x plus 6x square can be written as 1 minus 3x 1 minus 2x, right, in the factors. And moreover, taking the partial fractions, it will give you 3 divided by 1 minus 3x minus 2 divided by 1 minus 2x. that will be okay. So now we have a plus bx, right? So or ax plus b, ax plus b. So that is the format which we want, because our formula was valid for ax plus b. So using the same number of same formula for m equal to -1, this will comes out to be what? So let me give you for this one first and then this one. So y3, so 3 will be taken outside, into 3 will be taken outside, into -1 and factorial and a. What will be the value of a? A is equal to -3. So -3 per power n, right? Ax plus b equal to 1 minus of 3x and minus n plus 1. That is 1, right? This is the same thing written here. So and this is the same thing, right? Because this one is nothing but it is 1 divided by 1 minus 3x n per power 1. Similarly, 2 into -2 per power n minus 1 per power n factorial n and so on. We can take the common of -1 per power n plus 1 factorial n, right? And this will gives you 3 divided by 1 minus of 3x per power n plus 1 minus 2 divided by 1 minus 2x n plus 1. So finally yn is nothing but this is -1 n plus 1 factorial n into 3 divided by the fractional term 1 minus 3x and the whole per power n plus 1 minus 2 divided by 1 minus 2x and the whole power n plus 1, right? So that is your answer, and it will comes out using the derived result for the polynomial ax plus y equal to ax plus b per power m, where m was -1 only. Similarly, in this slides we had for exponential function. So if y equal to e per power x, then find out yn equal to a per power e per power x. Let me give you some of the idea how we had reached at this conclusion. So y1 can be written as what? A into e per power ax, right? y2 is written the same thing, a into a e per power x. Similarly y3, so this is equal to a square e per power ax. Similarly y3, this can be written as a square into a e per power x. So this is equal to aq e per power x and so on. So for yn, a per power n minus 1 into a into e per power x, this is equal to a per power n e per power x, right? So that means for a exponential function, it is quite easy to use that, and derivation is quite easy. Similarly, y equal to a per power x, y equal to a per power x. The constant must be in the logarithmic function. Remember this one. Whenever you have the variable on the as a power of any constant, then the constant which we are looking for in the nth derivative must be in logarithmic type of things. So e per power ax, how to I believe that you remember that one, that to find out dy by dx, firstly we have taken this one as logarithmic both sides and then use the differentiation both sides. So for this taking logarithm both sides, so this will give you log of or ln of y is equal to x into log of a, right? And this will be taken 1 by y dy by dx is equal to how much? You remember this one, right? This is the two things. So log a is a constant, x is just a variable. So this will give you log of a, right? So dy by dx is equal to log of a into y, and y, what will be the value of y? Y is nothing but a per power x. So this is your first constant. Similarly, the second constant is log a into log a. So if you find out y2, then that means d of dx y1. So this will be d of log of a into a power x into d of x, and log of a is a constant, and d of ax by dx, and d of ax by x is given here. See? So how much the value? This will be giving you log of a into log of a into ax. So this will comes out to be log of a ka whole square into ax. And in a similar manner, you can find out for yn. So yn become log of a power n a power x, right? So these two you must remember. If the function is y equal to e power s, that is, it is in the exponential form, then y of n nth derivative of that function y is equal to a power n e power ax, and if it is a power x, then the function is, the constant become log of a power n into a power x. Similarly, exponential function, we had already proved this one, and then logarithmic function. So now look at the structure of this function. The function is y equal to log ax plus b. Here ax plus b is an argument in the log, right, log function. So y1 can be written as a divided by, so y1 can be written as a divided by ax plus b. How we had find out? So y is given as a log of ax plus b. So taking dy by dx as a d of log of ax plus b divided by, since log of x is known, so that's why we are going to use the chain rule, right? So log of a, so this is the same quantity, so this is log of a, log of x means 1 by a, so this is ax plus 1 by ax plus b into d of ax plus b is equal to what? A. So that is the thing. Similarly, can you find for dy by dx? y2, y2 is also the minus of a square divided by ax plus b ka whole square, right? And similarly, in the similar fashion, you can find out the yn. Yn is, okay, so let me find out y2 first. So d of dx for a divided by ax plus b, right? A is the constant, so I have to find out 1 divided by ax plus b. 1 divided by ax plus b, we had already have this formula, right? Either you can use this directly the formula, or either you have remembered that 1 beta x is going to be differentiable, right? So this will gives you a square divided by ax plus b ka whole square, right? In the similar manner, y of n equal to minus 1 by power n minus 1 n minus 1 ka factorial, y of n divided by a of n a by power n and ax plus b by power n, right? So now use those existing formula and find out if y equal to x by power n minus 1 log x, then find y of n. So y is given x n minus 1 into log x. Now differentiating this y with respect to the x. So each one of this, so x n minus 1 into log x, there are two functions, right? So use the two function. Y1 equal to what? Y1 equal to, let take this is u and this is v. So y equal to u dash into v plus of u into v dash. So u dash is equal to what? U dash equal to n minus 1 into x minus 2 into log x plus of u is equal to x n minus 1 into of v dash equal to 1 beta x. See, this is the v dash, this is the u, this is the u dash, this is the v. So take this x, I am simplifying this by the taking the x in the other side. What it will give you? This will give you x into y1 and multiply here x. So x n minus 1, it becomes x minus 1, right? It becomes x minus 1 into log x plus x minus 1. Taking x n minus 1 as a common, you will get x into y1 right, is equal to x n minus 1 common, and this will give you n minus 1 log of x plus of 1. Now differentiating n minus 1 times. Now differentiating this one as n minus 1 time, and you will get y of n in the form of a complex mathematical formula, but y of n is just coming out like n minus 1 factorial by x. So here the function y equal to xn minus 1 log x seems like a complex one, but its nth derivative is a very simple, just containing 1 by x, n minus 1 factorial x. So I believe that this is the a very good method and very applicable everywhere whenever you need the nth derivative or the higher derivative of a given complex functions. So just remember some of the complex functions, something like y equal to ax plus b, that is a polynomial per power m. So y equal to ax plus b per power m, you will have the y of n, nth derivative of that function, and similarly y equal to e power x, y equal to a power x, y equal to log of ax plus b, and so on. So thank you so much.